Firstly, Jonathan and May added 3 to 4 scoops of each drug to each test tube using the metal spatula given, and placed the test tubes in order in the test tube rack. They added DI water to each test tube to dissolve the drugs. The drugs dissolved only partially. The first test is for carboxylic acid using red litmus paper. This picture here shows the litmus papers after they were dipped into the solutions, and here is me tilting test tube C to dip the blue litmus paper into the solution. The blue litmus paper turns red, thus we can conclude that C contains carboxylic acid, and therefore we can identify it as aspirin. Drugs. Here, May adds a few drops of aqueous iron chloride to test tube A and shakes it a little. As we can see, the yellowish-brown solution turns darker to a greyish-brown. Although that was not the color change we were expecting, which is violet, drug A is the only one that reacted with iron chloride, because for B and D, the iron chloride remained yellowish-brown. Thus, we conclude A contains phenol and is paracetamol. Now we have 2 unidentified drugs left. Jonathan and May prepared new samples of the drugs by adding the drugs once again to 2 new test tubes by adding DI water to dissolve. Here, Jonathan sets up the following apparatus as such: filling the beaker with water, then clamping the test tubes to retort stands, and submerging half the tubes in the water. Let the heating begin. When the water bubbles, Jonathan adds 5 drops of sodium hydroxide to test tube B, then uses a glass rod to stir, and our dear friend Ryan gladly helps by placing a moist red litmus paper at the mouth of the test tube immediately. Here, one must be cautious. Do not be mistaken, as the red litmus paper turns blue only because it touched the side of the test tube that still had drops of sodium hydroxide. For both B and D, the litmus paper remained red. Jonathan and May went back to their worksheet to look at the structures once again. They decided that they will use an oxidation reaction to test for the secondary alcohol present in ambroxol and not loperamide. They prepare fresh samples again and heat the test tubes once again. Here, Jonathan adds 2 to 3 drops of purple acidified KMNO4 to each test tube. The solution changes from purple to light brown in B, while it remains purple in D. This proves that D cannot be oxidized, and thus we conclude it must be the one with a tertiary alcohol. So D is loperamide. This means B is ambroxol.